Today we're going to try something really crazy. 23.9, close enough. These are very close to true O scale. You don't want to try this with a modern transformer. So this is based off of a real O caboose from 1916 up to 1938. That is not helpful. Now it is truth or consequences time. Part of the circuit is running through this wire arm here. Very simple but effective animation for the layout. Hello again, this is Mike with Toy Train Tips and Tricks. And today I'm going to take care of some subscriber requests. A lot of folks have written in and asked about my control panel and my wiring. And I haven't featured this before because it's still a work in progress. But to give folks an idea of what's going on here, I'll go ahead and kind of show you what's going on. So first of all, we have the panel itself. This is a sheet of masonite with a wood frame. Pretty simple construction. And then for the track diagram, I painted the whole thing white. And then I taped out with painter's tape a schematic of where the tracks go and what they do. My main lines are the thicker tape, and the little branch lines and sidings are the thinner ones, so that I know what's going on there. Here's my yard. And then I painted black over everything, let it dry, peeled the tape off, and now I have white lines on a black background. So that's the basic schematic, and of course everybody's layout is different. Now you could, especially since my layout is basically two loops, I could have done the schematic as the two circles. I did it laid out this way, left to right, more as a reflection of my days as a HO scale modeler. My layout, I really operate it two different ways. Most of the time, because I'm short of time with my work and family and everything else, most of the time I only have 10 or 15 minutes here and there to just pop on a train, and I call that display mode, where it just runs loop and loop and loop and loop and loop. However, every once in a while, I have a couple of hours that I can kill to myself, and then I like to go into what I call prototype operating mode. And so this schematic works really well with that because it gives me the idea that the train is going somewhere. I've set it up from left to right is west to east. So the left side of the panel represents the west end. The east is on the right. Now, of course, realistically, once you get all the way to one side or the other, it flips around. A train, once it reaches the end here, it magically reappears over on this side. But it gives the illusion of movement in a particular direction like a real railroad. Okay, so let's talk about how the actual wiring goes. Just a quick overview. Again, everybody's layout's a little different, but you can kind of get the idea of the basics here with what I've got going on. So let's go to my power pack. I've switched back to the TAC2 here, close to my panel, just so that when I'm operating by myself, close to the panel, I can have easy control of two trains. So wiring up from throttle 1, you see my blue, because I ran out of black wire, blue is a substitute for common, and in this case green is the hot. I'm using different color leads for the different throttles. So throttle 1 is green, and again the blue or black, depending on where I'm, because I ran out of black wire, is my common. In this case, before it goes to the layout, it runs first into this K-line whistle and bell controller for two reasons. One, I like the push button operation better than the slide switch on the TAC 2001. Secondly, the K-line, you can switch the polarity so you have control over both whistle and bell on locomotives that are equipped with the two different sound effects. So this is the input from the transformer. I need to tighten that. So this is the input from over here. It runs through here and comes out here. Now this little device is called a TVS. That is a transient voltage suppressor diode. And the purpose of that is to take care of any voltage spikes that may be coming from the power pack, so that if I'm running a more modern locomotive with a circuit board, that surge or that spike in power doesn't fry the board. So I do that on all of my outputs. These TVS diodes, if you buy them by the dozen, they're like less than $1 a piece, and it's really cheap protection. So think of this as your surge protector. Now, if you're running all post-war and MPC stuff without the modern circuit boards, you really don't need it, but you know, it's helpful for that. Okay, so from here, again, my green is my hot from throttle 1, my blue/black is my common. So where do those go? Well, let's take a look down here. My blue and a whole lot of other blues and blacks go to this plate. This is part of my common bus for the layout. This is where I have it right here next to the layout. This is a steel plate left over from a shingling job on the old house, and I have this similar plates all around underneath the layout. If I can find one right here, yeah, there we go. Every couple of feet I have put those, and they are all wired together all the way around. And you see the heavy, yeah, you see the heavier gauge wire there. And so anywhere on the layout, whether it's from a track or accessory or from whatever, a turnout, if I need to excuse me, wire up the common side of the circuit, I just find the nearest plate, wrap it in, screw it in, and it's in. So this is my common bus. This wire is my common for my control panel, which you will see here shortly. And then here we have our green. This is our throttle 1 lead, and it goes to this bar over here. All right, so let's take a look at the panel real quick. Now, I'm a little crazy in this respect in that even though I have a relatively small layout, I am wiring up 5 different power packs to have the option of running track power. Why would I do that? Well, again, everybody's layout's different. Most folks with 2 lines would be just fine, you know, having the option of 2 throttles, or just saying this main line is throttle 1, this main line is throttle 2, and maybe a couple of on-off switches to kill things in the yards. But again, from my days in HO, when running realistically, actually with this track plan, believe it or not, I could run 3 trains at a time without colliding with 3 different operators and a dispatcher. I could keep 4 people busy all at one time if I'm doing it right. Another reason is this setup is great if I'm by myself. I've got the 2 power, and then the control panel right here next to me. But what if I have the kids or say grandkids or guests or whatever come over and operate with me? Everybody standing right here would get very, 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 very crowded. Now I do have the option, I do have my 1 wireless throttle here, but still having 1 person here, 1 person being the dispatcher, it gets really crowded. So I plan to put 1 throttle over on this side of the layout, right about here. And I plan to put another throttle right here in this corner. It also gets it closer to the action with the drawbridge and things like that. So I can spread my operators out over a larger area if I have multiple people involved. So that's part of the plan. So to do that, I have these rotary controls. And these rotaries control which power pack is feeding power to each section of track. Now notice these black lines. This denotes that this section of track is 1 block. You cross the black line and you're in a different block controlled by a different rotary. Cross the line, you're in a different block controlled by a different rotary. So you can see where I can control different locomotives different trains, and with having all of these different blocks to control, the yellow dots with the R is for rotary, where I haven't put them in yet, but that's for future expansion. So I could have, in this case with this rotary, actually up to 6. These are 6-position double pole rotaries. Now in my case, the 6th position will be off. So this gives me the option of spreading out operators. It also gives me the option of using different power packs with different types of power. If I'm running a locomotive that works well with the wireless, I can do that. If I'm using NPC or post-war, this works, or Lionel post-war transformer. If I'm using something more modern, it may respond better to a modern type power pack, so I can mix and match. Someday, if I decide to go to command control, I can simply wire in the constant power to one of these positions and call that my command control block. So it gives me a lot of flexibility. It's a lot of extra work up front, but it gives me a better payoff in the end, and basically gives me all of the flexibility that I would get with command control, but with conventional control, because I can have theoretically up to 6 different trains operating on any particular spot. I could have 6 engines all powered at the same time, theoretically, with this setup. Okay, so how do I pull that off? Well, you see these bus bars under here, these terminal strips, and the red wires, these are all hot to the track. And the different blocks, each has its own wire going to the different blocks on the different sections of track around the layout. Now, how do I keep track of what is what? Well, that's what my notebook is for. As I wire it up, I keep a notebook, and in this case, terminal block 1, which is the one on the left-hand side, it tells me here are each of the different spots, each of the different screw terminals, and it tells me, well, this one is blank. This one goes to block number 7, which is on main 1, the outside main, south strad, which is over there. And so I have different locations marked out so that I know where each one is. And if a block is large enough that it has multiple feeds, I note that. See, 2 feeds to that one, 2 drops to that one, 2 drops to that one. So that tells me if it's a bigger block that I use multiple feeds. I want to put feeds at least every 5 feet, sometimes even closer, just to give myself some redundancy so that if something breaks loose later, I'm not crawling under the layout to find loose wires. I'm in an unfinished, unheated basement. Temperature changes. Summer, winter, things move back and forth a little bit. Sometimes those solder joints can pop off and such, so redundancy is good. Okay, so back to my terminal block here. The red wires go to the track. Now these white wires come up and they go to my control panel, to my rotary switches. And what they do is they go to the middle contact, and then as you turn the rotary, it selects which of these outside contacts, if you can see that, which outside contact is receiving power. And so remember how green was transformer 1? So in this position, it feeds from green. Here's all of my greens in a bus up here, and it goes down, and this is where all of my power packs will tie in. Pack 1, 2, 3, 4, 5, and actually here on the end, these are temporarily wired in so I can direct wire to the middle loop. So these will eventually be removed. And you see I have it marked as power. Okay, so the green throttle comes from my throttle here, goes up into my bus, and these are all connected together. Whoops, you got to be able to see that. It goes up here, these are all connected together, and from here it goes to the different rotaries. And when the rotary is selected to green, power from throttle 1 goes to the track for that block section. Okay, these gold wires, this was a temporary setup, and those are going to be removed once I've got it all set. So I've got my green up here. Well, my other throttles, as I get them in here, will be different colors, and we'll have different sets of buses, 1, 2, 3, 4, 5, all the way down, and we'll go to all of the different blocks on the back. The blue tape is here to remind me where the track diagram is on the other side of the board. So if I need to install a component, like if I were putting the bus bars here, I know I can't put one here because that's where the track is, and I might have to put a rotary in later, so I need to leave that spot clear. So that's a little reminder to me to not put any type of terminal block, bus bar, or anything like that on this side of the panel in that spot, because it may interfere with a rotary that I have to install on the other side at a later date. Okay, like I said, this is a work in progress.
Okay, so having watched the raw video of what I shot, I realized that following the different wires around the control panel can be clear as mud. So what I've done here, I've put together just a very basic schematic to get the basic idea of what I'm doing across. So I've simplified it down to 2 transformers and 2 independent blocks of track. These are insulated from each other, isolated from each other. But this allows me to operate either track, either block from either power pack. And then you can expand this for however many power packs you have, however many blocks that you have, but follow this basic idea. So in this scenario, 2 power packs switching between 2 independent blocks and everything you need for that. So my 2 power packs, you notice the common side, the black, they are wired together. We are in phase, and that goes to my common bus terminal. In this case, the plate that is next to my power pack, and then that is wired to several other plates about every 3 feet apart around the layout with a heavy gauge, 12 gauge wire. So they're all wired together. So any place that I need to connect to common, whether it's track, whether it's accessories, I'm never more than about 3 feet away from one of these plates where I can tie in. Saves a lot of wiring and simplifies things. So my 2 power packs, the common posts go to the common bus plate. Each hot goes to, and you see these are connected, this would be represented, this would be a bus. And then for each block goes to a selector switch. So the hot for this power pack goes to both selector switches, and we'll talk about those in a moment. And this one goes to another bus, which connects to each of the 2 selector switches. Now, if I've only got 2 options here, I can use a simple double pole, single throw switch. I can throw it this way to connect to this power pack, throw it this way to connect to this power pack, and so forth. In my case, I'm actually using double pole 6 throw rotary contacts. Now, the second pole I'm not using right now. I may use it someday to help control a signal system, but we'll see. So I'm only using one of the 2 poles, but I'm using the 6 throws, 5 power packs and 1 off position. It's wired to nothing, but I can turn the rotary there. I know the track is dead in that section, and I don't have to worry about anything cross feeding from one to another or whatever. Okay, so each selector switch, the hot side goes to a block. So this selector switch controls the hot side to this block. So if I want this power pack to control this block, I throw the selector switch, bing. And so the hot goes from my center rail to my selector switch to the hot side of this power pack only. If I want this power pack to run it, similarly, it runs from here to the selector switch, throw it this way, it connects here to the hot of this power pack, and vice versa. The outside rails, again, connect to my common bus. All of my commons are tied together in one circuit, saves a lot of wiring, and makes this a lot simpler. So I really only have to worry about what's going on with the hot side of my circuit and my selector switches. Don't have to worry about the common side at all. Okay, so I hope this clarifies things a little bit. And again, this is not exactly what I have, but The general principles will apply to any layout. Since you don't want to copy mine because yours is going to be different. But this lays out the general principles for what you need to do for the separate block control. And I hope that helps.